So continuing stoichiometry, we've talked about mole to mole ratios. We've converted from grams to moles and moles to grams. In this lesson, we're going to look at converting from mass and volume and IPAM to one of the other three. So we're always going to follow the 3 steps: convert given to mole, use the mole ratio, and then convert to the unknown unit. So here in our first problem, it says what mass, and remember mass is measured in grams, so we're looking for grams, of water is formed when hydrogen reacts with 384 grams of oxygen. So listing our givens, 384 grams, and we're looking for grams of water. The first step in stoichiometry is to always convert your given to moles. So that's going to be our first step. So we start with a given, and we're going to go from grams of oxygen to moles of oxygen. Bring grams to the bottom, so when we divide they cancel out. Moles of oxygen on the top. If we look at the road map here, 1 goes with mole, and the molar mass from the periodic table would go with grams. So for oxygen, we're doing 2 oxygen, so we would say 16 plus 16, or 16 times 2, is 32 grams per mole. So 1 mole is 32 grams. That's the first step. Second step is to use that mole ratio. The mole ratio is when you can change the substance. So instead of oxygen, we want to know information about water. So you bring your given to the bottom, and then your unknown substance goes on top. In a mole ratio, you always use the coefficients from the balanced equation. So we look at our balanced equation. 1 would be the coefficient in front of oxygen, and 2 is the coefficient in front of water. So 2 moles of water to 1 mole of oxygen. Then we can do our third step, which is to convert to the unit that the question wants us, which is grams. So we don't want to stop at moles of water, we want to go to grams of water. So now we're going to convert from moles to grams. So we bring moles to the bottom, and we put grams of water on the top. Then again, looking at our map, 1 goes with mole, and the molar mass goes with grams. So the molar mass of water would be 2 hydrogens, and I'm just going to multiply this time, plus oxygen. And so we get 18.016 grams. Now when we multiply and divide, multiply the top, divide by the bottom, our grams of oxygen will cancel. Multiply the top, divide by the bottom, moles of oxygen cancel. Multiply the top, divide by the bottom, moles of water cancel, leaving us in grams of water. So our answer, when we multiply and divide, is going to give us grams of water. So we take our calculator, 384 times 1 divided by 32 times 2 divided by 1 times 18.016 divided by 1. We want 3 significant figures because that's the amount of our given. And so we would have 432 grams of water. Let's look at another question. How many particles of tin 2 fluoride? So under tin 2 fluoride, we're going to write particles are produced from the reaction of 30 grams of hydrofluoric acid. So under hydrofluoric acid, we'll put 30 grams. And then we go through our 3 steps. The first thing that we need to do is make sure our given is converted to moles. So we start with the given. Grams would come to the bottom, and we want to convert it to moles. We look at our road map. 1 mole, and the molar mass goes with grams. So 1 would go with mole. We would look on the periodic table, and for HF, we would say hydrogen plus fluorine, and that would give us 20.008 grams. That's the first step, convert given to moles. Second step, use the mole ratio. So now we're going to set up our mole ratio. So moles of the given on the bottom, mole of the substance we're looking for on the top. When you have that mole ratio, you use those coefficients from the balanced equation. So 2HF, 1 SNF2. So 1 tin fluoride to 2 hydrofluoric acid. Then we want to do the third step, which is convert to the unit the question is asking us for. So we're going to bring mole of SNF2 to the bottom. We want to know particles, so we're going to put particles on the top. SNF2. So now we're looking at our roadmap again. 1 mole, and then particles is down here with Avogadro's number. Remember IPAM. Ions, particles, atoms, and molecules, we use Avogadro's number. So 1 would go with mole, and then Avogadro's number goes with particles. So then we're going to multiply and divide. So we would say 30 times 1 divided by 20.008, that will get rid of our grams, times 1 divided by 2 gets rid of our moles, times 6.022, remember that special button, which is that double E, 23, divided by 1 would get rid of the moles and leaves us with particles of SNF2. We want 3 significant figures. The zeros are significant because there's a decimal. So our answer would be 4.51 times 10 to the 23rd particles of SNF2. All right, let's look at another example. In a spacecraft, carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide according to the following equation. 448 liters of CO2. So under CO2 we write 448 is exhaled, the average amount exhaled by the person each day. How many grams of lithium carbonate is produced? So under lithium carbonate we're going to put grams. Now it says at STP. Don't worry about at STP. We will talk about that later on, and it does not change how we actually solve this problem. So we're going to say 448 liters of CO2. You always have to start with your given. Set up your table. First step is to convert to moles. So we're going to bring our liters of CO2 down to the bottom, mole of CO2 to the top. Converting our given to moles. We look at the roadmap. 1 mole is 22.4 liters. So 1 with mole, 22.4 with liters. Then we use our mole ratio. That's step 2. So moles of the given on the bottom, moles of the unknown on the top. When you have a mole ratio, you use those coefficients from the balanced equation. So 1 CO2, 1 lithium carbonate. They just happen to both be 1s. Then we want to convert to the unknown unit. So the question is asking for grams, so we got to do one more step, and we got to go from moles to grams. Looking at the roadmap, 1 goes with mole, molar mass goes with grams. So we can put 1 on the bottom, and then we use our periodic table to find the mass of lithium carbonate. So 2 times the mass of lithium plus the mass of carbon plus the mass of 3 oxygens. And that would equal 73.892 grams per mole. So there's 73.892 grams for every 1 mole of lithium carbonate. Now, when we go and multiply and divide, 448 times 1 divided by 22.4 gets rid of the liters. times 1 divided by 1 gets rid of moles of carbon dioxide, times 73.892 divided by 1 gets rid of the moles of lithium carbonate, leaving us with the unit of grams of lithium carbonate, which is what we're looking for. We need 3 significant figures based on the given. I know in your calculator it tells you 1,477, so we're going to round that to 3 significant figures. 1,480 without a zero, without the decimal, the zero is not significant. And so that would be grams of lithium carbonate. All right, I have one more example. How many liters of water? So underwater we can put liters, and then are required to produce 5.0 times 10 to the 23rd molecules of H2. Now molecules is not the same thing as moles, so we're going to have to do step 1, which is to convert to moles first. So we start with our given, bring molecules to the bottom, and we want to convert it to moles. We look at our roadmap. 1 mole, Avogadro's number of molecules. Remember, molecules is a part of IPAM. So 1 mole is 6.022 times 10 to the 23rd molecules. Then we want to use our mole ratio. So we bring moles of hydrogen to the bottom, and we want moles of water. So the mole ratio is when you can switch substances. We use the coefficients when we do mole ratios. 2 waters, 1 hydrogen. So 2 and 1. Then we want to convert to the unit that we're looking for. In this case, the question wants liters. So again, looking at our roadmap, mole to liters. So 1 mole is 22.4 liters. So that unknown unit and substance should always be what ends the problem, ends the table. So now when we go through and we multiply, don't forget to use that special button, which is that EE button or EXP button on these 2 values. So 5.0 special button 23 times 1 divided by 6.022 special button 23 gets rid of the molecules, times 2 divided by 1 gets rid of the moles of hydrogen, times 22.4 divided by 1 gets rid of the moles of water, and we're left with liters of water. We want 2 significant figures this time because the decimal, the zero, is significant, so our answer would be 37 liters of water.